Good morning, children. After discussing about rational numbers and irrational numbers in detail, let's derive some facts between them. The four fundamental operations in maths are addition, subtraction, multiplication and division. Let's see what will happen when two rational numbers are added, subtracted, multiplied or divided. Let's take the example of the first rational number as 1 by 2 and the second rational number as minus 3 by 7. If you find the sum of them, 1 by 2 plus minus 3 by 7 as LCM is 14. You are getting it as 7 minus 6 by 14. The answer is 1 by 14, which is again a rational number. With the same numbers, let us find the difference as 1 by 2 minus 3 by 7. The answer will be the same as 7 plus 6 by 14 or 13 by 14, again a rational number. The product of 1 by 2 and minus 3 by 7, 1 by 2 into minus 3 by 7, minus 3 by 14, again a rational number. The quotient of 1 by 2 and minus 3 by 7, the calculation as multiplied by the reciprocal, and minus 7 by 6, again a rational number. Thus, when two rational numbers are added, subtracted, multiplied or divided, the resulting answer also will be a rational number. Let's take one number as rational and another number as irrational. What will be the results for the same operation? Suppose you take the rational number as 2 and the irrational number as square root 2. The rational number 2 and the irrational number square root 2. What about the result or the answer found here? The sum of 2 and root 2 is 2 plus square root 2, 2 plus 1.414, etc. That is, the value of square root 2 is not a terminating one. Thus, when you find the sum of a rational number and an irrational number, again you are getting a result of an irrational number. Similarly, the same example if you take for the difference, 2 minus square root 2 is the same as 2.00 etc. minus 1.414 etc., which shows that the answer is again an irrational number. What about the multiplication? With the rational number 2 and square root 2, the value of 2 is fixed, but the value of square root 2 is not fixed. Hence, we cannot get a rational number. The answer is again an irrational number. Similarly, if you find the quotient of 2 and square root 2, the value of 2 divided by 1.414, etc. is again, and it is not a rational number, it is an irrational number. Thus, when you add or subtract or multiply or divide a rational number with an irrational number, the result is always irrational. A general rule, like we explained before, cannot be derived if we take two irrational numbers. When you take the following examples, you will come to know. Let us take an irrational number as square root 2 and another irrational number as square root 3. What is the sum of square root 2 and square root 3 is square root 2 plus square root 3, which cannot be further simplified, or the answer remains as irrational. Similarly, if you take the difference of square root 2 and square root 3, again it cannot be further simplified, or the answer remains as square root 2 minus square root 3. Consider the product of square root 2 and square root 3. Square root 2 into square root 3 is the same as square root of 2 into 3, which is equal to square root of 6, which is again irrational. But if you consider the first irrational number as square root 2, one more irrational number as square root 2, or if you multiply square root 2 twice, it's the same as square root of 2 into 2, square root of 4 is equal to 2, which is a rational number. That means the product of two irrational numbers can be either irrational or rational. In a similar way, what is the quotient of root 3 by root 2 is square root of 3 by 2, which is again irrational. What about square root 3 by square root 3, which is the same as square root of 3 by 3, which is square root of 1, which is equal to 1, which is a rational number. Thus, we cannot define a general rule regarding the addition, subtraction, multiplication and division when two irrational numbers are involved. Please underline the properties given in your textbook, page number 19. They have given you the three properties under page number 19. These are the worked out example in your textbook. I will work out. You can learn it as such before beginning the exercise. Before that, these facts should be always there in your mind. Let a and b be two positive real numbers. Root a plus root b is the same as root a plus root b. Root a minus root b is the same as root a minus root b. Root of a into root b is the same as root of ab. Root a divided by root b is the same as root of a by b. How to expand or how to simplify the following expressions? 5 plus root 7 into 2 plus root 7. The meaning is it's a binomial with a binomial, which shows that there are two terms here, two terms here. Before you go directly, the first number you just distributing log the first number to be multiplied with the second number plus root 7 into 2 plus root 5. You also can do directly, but till you study thoroughly, first number you will multiply with the first full second by distributive law. The second number also you can do. 5 into 2 is 10. 5 into root 5 is 5 root 5 plus root 7 into 2 is 2 root 7 plus root 7 into root 5 is root 35. 10 is a whole number. 5 root 5. The rational part is 5. Irrational part is root 5. Irrational factor root 7. Irrational factor root 35. None of them are the like terms, or the answer is remaining. That is, addition of irrational numbers cannot be simplified further. It can be simplified if the irrational factors are same. The next question, 5 plus root 5, 5 minus root 5. those are very thorough with the identity of a plus b into a minus b. Directly you can write the answer as a square minus b square, which is the same as 25 minus 5, 20. Or the second method is, as I explained, the distributive law. 5, the second method, 5, you will use distributive law with 5 minus root 5, with root 5 with 5 minus root 5. 5 5s are 25. 5 into minus root 5 is minus 5 root 5, plus 5 into root 5 plus into minus is minus 5. When you see here, 25 is a whole number, 5 is a whole number. 25 minus 5 is 20. Again, minus 5 root 5 plus 5 root 5, which shows that their irrational factors are same. They are like terms. So you can subtract the rational part, 5 minus 5, as 0. It is 0 root 5, or that term do not exist. Or in the same way, you can just cancel since they are unlike terms. At the same time, the irrational factors are same. Thus, this way also you can arrive at the answer 20. A similar one can be seen here. Identity, root 11 the whole square minus root 7 the whole square. Root 11 the whole square is root 11 into root 11 is simply 11. Root 7 into root 7 is 7, or the final answer is 4. This is of the form a plus b whole square. What is identity a plus b whole square? Identity a plus b whole square is a square plus 2ab plus b square. Thus, you can expand root 3 plus root 7 the whole square as root 3 the whole square plus 2 into root 3 into root 7 plus root 7 the whole square. Root 3 the whole square is 3. Root 3 into root 7 is root 21. 2 root 21 plus root 7 the whole square is 7. 3 and 7 are whole numbers. You can add 10 plus 2 root 21. Further, you cannot simplify as 10 is a whole number. 2 root 21 is an irrational number with 2 as rational factor and root 21 as irrational factor.